Hey everyone, welcome back to another video. Today we're going to be doing some practice diplomas, and yeah, it's mainly practice diploma questions for the unit of transformations, the first unit. And yeah, I guess we'll just dive straight into it here. Now, this first question here, we have the point 3, 8, which is going to be transformed to a certain point on the graph of y plus 3, b to the x plus 1. So we have this original equation, which produces this point, and we have to find our new point after the transformation is given. So now, what we're going to do is we're going to, I would subtract 3 from both sides to get our nice -3 isolated. So now you can see that from our original equation, there was no horizontal translation, but now there is a translation of x plus 1, meaning our h value is going to be -1. Since we're adding to x, it's going to be -1. And now our k value is going to be -3. Since we subtracted 3 from both sides, we're going to be moving down 3 units. So if you were to write it out in our mapping, like our coordinates, we're horizontally translating 1 unit left, so x minus 1, and then we're going down 3 units, so y minus 3. And that's what we're going to do to this original point. So if we're subtracting 1 from x, the point becomes 2, comma, and then y minus 3. So if y is equal to 8 on our original coordinate, we're going to subtract 3, and we get 2, 5, which is b, and the answer should be b there. So now this one, it says the function f of x has a domain of x is between 2 and 6, and a range of y is between 4 and -8, or -4 and 8, sorry. And we're asked to find the domain after a transformation of -f of x, f of 1/2 x. So in this case, I'm going to notice that our a variable is going to be -1. So that's a is -1. And our b variable, our horizontal stretch, is going to be b is equal to 1/2. Now, if I were to write a description of what is going on here, I'd say that there is a horizontal stretch by a factor of 1/b. So in this case, 1/b will be 1/2, 1/1/2, which is going to be 2. So horizontal stretch by a factor of 2, and a reflection in the x-axis. So in this line here, we're going to reflect in this line here. So a reflection in x-axis. Just a rough description, which will help me make my mapping notation. So I'd say that our point x, y is going to undergo this transformation here, where we're going to have a horizontal stretch of 2, so 2x, and then our y value is just going to be -y. Since a is -1, we're going to be multiplying all of our y values by -1, and therefore reflecting it and flipping it in our x-axis. So if you were to apply this to our domain, so our domain values is between 2 and 6. And if we were to multiply this by 2, 2 times 2 is 4, and then we would get 6 times 2 is 12. So our domain should be from 4 to 12, which is good. So our D answer is looking like a possible good answer here already. But I want to test out the second part of this. So our mapping notation states that we have -y. So now we're going to multiply both our y values in our range by -1. So I'd get, you have 4 times -1, which becomes -4, and then 8 times -1, which becomes -8, or -4 times -1 should be 4. So now you get 4 and -8, meaning the lowest point should be -8, and the highest point should now be 4. And the domain that matches this is going to be D. So again, we're just applying these transformations onto our domain and range respectively. So for this question here, we're asked to express g of x in terms of f of x. So we're looking at the transformations that need to be applied to this graph of f of x in red here to get the graph of g of x in blue. So just looking at these 2 points, I want to look at the points that are common between the two. So I can see that both of these vertexes, so the vertex on the graph of f of x, and I'll write out the point, is going to be -5, 10. And we're going to the point g of x, so we're transforming to the graph of g of x, and our point of vertex on the graph of g of x is going to be -10, 20. So I guess you could see that to go from f of x to g of x, you're multiplying the x value by 2, and you're multiplying the y value by 2 as well. The way I describe this, or the way I'd write out this mapping notation, is x, y, then turns into 2x, 2y. Or now that we have our mapping, I'd write out my description. So I'd say there's a horizontal stretch by a factor of 2, and a vertical stretch by a factor of 2. Remember, a horizontal stretch is going to be by 1/b. So we're saying that 1 over b is equal to 2. If 1 over b is equal to 2, then our original b value would be 1 over 2. And a vertical stretch is just going to be by a factor of a, our a parameter. So this is just going to be what a is equal to. So a is equal to 2. Now, if we were to write this in terms of f of x, we'd say that 2 f of x, which is 1/2 x, should be equal to g of x, just based off these transformations we described. And based off our answer should be D. And the reason we're not translating it 10 units up is because this whole graph of f of x would be moved 10 units up. Every point of this graph would be moved 10 units up, and that's not what this graph shows. So there's two stretches going on here. So again, this is one of the applying mapping notation questions where you have to like apply mapping notation. So the point A is going to be transformed to an image point A prime after undergoing these transformations. So we have this original graph, which is y equals f of x. Y equals f of x. And that beholds the point -3, 4. The corresponding image point, point A prime, is what we're looking for. So x, y, undergoes the graph of f of x under these transformations. So these transformations here, we have a is equal to 1/2. We have b is equal to 3. And just remember to factor out the 3 here, because we're always wanting to factor out whatever is in front of x. So it would be 3x plus 4 to get our true horizontal translation. So our h value here, since we're adding to x, remember, would be -4, just because of the nature of the y equals a f x, or a f b x minus h plus k formula. And remember that we're subtracting to x. So if x is negative, then a negative minus a negative becomes a positive. So to get x plus h, you'd have to have a negative value. So therefore, our x value here for h, or our h value, is going to be -4. So now that we have these parameters here, I could write out my mapping and say that x, y turns into, and for mapping, x, y is going to turn into 1 over b x plus h ay plus k. And that's really important to take note of, because our b value is 3 right now. So if you were to follow this formula here, let's say that 1 over 3 x plus h, and our h value is -4. So x plus -4, which just becomes x minus 4. And this would be our transformed x value here. In terms of our y value, we just say 1/2, y. And there's no and we have to add by the k value here. So our k value is equal to -1. So we're just gonna plug in our value. So k is equal to -1. So k plus -1, which is the same as subtracting 1 from this equation here. So if we plug in our values for our original point, which is -3, 4, and we plug it into the new mapping notation, we should get our new coordinates. So I'd say 1 over 3 times -3 minus 4 is equal to our new x value. So if you were to do this in our calculator, if need be, you say 1 over 3 times -3 minus 4. 1 over 3 times -3 minus 4. That's just going to be equal to -5. And our new y value, or our original y value, is going to be whatever this is plugged into our new equation. So we have 4. So 1/2 times 4 minus 1. So half of 4 is 2 minus 1 is just going to be equal to 1. So y should equal 1. So -5, 1 should be our final answer. So C should be the answer here. So now this question here asks us for the amount of invariant points that would be on the graph of y equals f of x if it was reflected in the line y equals x. So remember that y equals x is the linear line where every point of y is going to be equal to every point of x. So to draw this graph out, it should be pretty simple, right? So it should look something like this, because you'd be equal to 1, 1, and then 2, -2 should be equal, -3, -3. Then you have sorry, I should probably draw this better. To draw this graph, I just set every y value equal to every x value. So again, to draw this graph, this is a math 10 concept. We're just going to draw the line of y equals x. So 1, 1, you have 2, 2, 0, 0, -1, -1, -2, -2, -3, -3, -4, -4, -5, -5, -6, -6. So if we were to draw out this line here, we'd see that this line intersects the graph of y equals f of x 2 times. Remember from my last video that I said a point is invariant when it intersects the line of reflection. So in this case, it's going to intersect the line of reflection 2 times. So wherever it intersects the line of reflection, whether that be y equals 0 or x equals 0, the amount of times the original graph intersects the line of reflection, that's going to be the amount of invariant points you have. In this case, we're going to have 2 invariant points that we can count. So the restriction on the domain of the quadratic function, ax minus c squared plus d, that would ensure that the inverse is always a function, would be what? So to ensure that the inverse is always a function, it has to pass the horizontal line test, right? So if we were to draw out just a regular quadratic, just not worrying too much about the formula, regular quadratic is going to look something like this. And remember that our c value is going to be the x value of the vertex, and the d value is going to be the y value of the vertex, if you remember this from Math 20. So now, knowing this, we need to pick a point that ensures that it passes the horizontal line test, because if we were to pick a point here, it would cross, and when you flip it, it would not be a function. If you pick this point, it would cross and therefore not be a function once you flip it this way. So the only points that work is when you pick a point that is either greater than the vertex, because it'll have no points to. The only points that will work will be the points that are greater than the vertex. So anything that is greater than this, or any point that is less than this. And it has to be one of the two, because it can't be both, because otherwise, again, it's not going to pass the horizontal line test. So you have to look for a line that's greater than the x value of our vertex. So we're restricting the domain. So it has to do something with c. So again, the only one that has something to do with our vertex is going to be c. As if we were to inverse this graph here, the vertex restricted the domain greater than the vertex, you'd only get half of this graph. That's why our answer here should be c. So given the function 4 times 1/3 to the power of x minus 16 is equal to f of x, the intercept of the inverse to the nearest hundredth is. So we're looking for the y-intercept. Remember that when we're trying to find the y-intercept, we just set x equal to 0. So in this case, we have 4 to the power of 1 over 3 to the power of 0, and anything to the power of 0 is just 1. So 4 times 1 minus 16 equals y. Y equals 4 minus 16, which is just going to be negative 12. That would be the y-intercept for the graph of f of x. And what I want you to realize is that if you were to write out the mapping notation for an inverse, all that's happening is your y and x values are effectively being switched. So the y-intercept of the original graph would now become the x-intercept of the inverse graph. And inversely, the x-intercept of the original graph would become the y-intercept of the inverse graph. So to find the y-intercept of the inverse graph, what you can do is just find the x-intercept of the original graph. So we just say y is equal to 4 1/3 to the power of x minus 16. And now what we can do is we can set y equal to 0, because remember when you're finding the x-intercept, you set y equal to 0. So now you have 0 is equal to 4 times 1/2 to the power of x minus 16. Negative 16 is equal to 4 to the power of 1/3 x. 4 is equal to the power of 1/3 x. And if you're at this point, what you can do is you can just solve this in your calculator if you don't know how to use logs. So we're just going to do 4 as our y1 and 1/3 to the power of x as our y2 in your calculator. And I just want you to find the intersection between these 2 points. The intersection should be approximately negative 1.26186. So whatever value that matches up here, this answer should be a. But if you wanted to solve it using logs, what you could do is you could say log base 1 over 3 to the power of 4 is equal to x, and then do it from there. So let's say and that would give you the same thing. But if you don't know how to do that, that's perfectly fine. You can use your calculator. Now this is, again, just kind of applying your understanding of transformations here. So we're showing the graph of f of x, and g of x is going to be the graph of f of x under certain transformations here. So we have to find the new range of what g of x is. So the graph of y equals f of x currently has a range of, so the lowest point would be 0, and the highest point would be infinity. So now what we can do is we can take these 2 points and apply the transformations here. So if you notice in this equation, under these transformations, a is equal to negative 1, and k is equal to positive 4. So again, our mapping notation becomes x comma y, and then to 1 over b x plus h, ay plus k, and we don't have any horizontal translations or anything to do with horizontal here, so we don't have to worry about that. So this x stays the same, and y becomes ay, so negative 1 y plus 4. And this is the transformation we're going to apply to both of these values. So first, we have 0 times -1 plus 4. 0 times -1 is 0 plus 4 is now this. So we have 4 as one of our points of our range. And then now we're going to try infinity. Infinity times -1. It's negative infinity. Plus 4 is still just negative infinity. So we have 4 negative infinity as our answer. And we can't equal infinity, of course. So I don't know why I put can equal bracket here. And just remember when you're stating domain like this, or domain or range in this interval notation, all you have to do is you have to put the lowest value that comes first. Negative infinity is going to come first, obviously. And then you're going to have your highest value, which is going to be 4. So whichever one matches this should be our answer. And the answer should be D. So now f of x is drawn in quadrant 2 completely. And we want to look at the new functions that will be drawn and which quadrant respectively they will be after applying some transformations. So this new graph is, the first graph is translated 8 units down. So if we're moving 8 units down, just notice that k is equal to -8. That would translate to a vertical translation 8 units down. You can count this out. 1, 2, 3, 4, 5, 6, 7, 8. You would end up in quadrant 3, somewhere in quadrant 3. I'm not going to draw it out, but you would end up in quadrant 3. If you were to translate the whole thing 8 units down. Now, if you were to completely translate it 8 units to the left, since h in this equation here, f of x plus 8 is our transformation, h would be -8. Since again, remember, in our transformations equation, to get x added to something, you have to have h being a negative value. So h is going to be -8. And if we have a negative h value, that means we're moving to the left. So if we're moving to the left 8 units, that's not going to change the quadrant that we're in. So we're going to stay in quadrant 2. Now for this final transformation, we have f of -x. So f of -x, what does this mean? This means that our b value, which is being multiplied to x, is going to be -1. So if b is -1, then we have a reflection in the y-axis. Because remember that when you have b, you're dealing with either a vertical stretch, or when you're dealing with b, you're either dealing with a horizontal stretch or a reflection in the y-axis. So a horizontal stretch about the y-axis or a reflection in the y-axis. So in this case, we're reflecting in the y-axis since it's negative. So if I were to draw this out, y-axis is going to be right here. And if you were to reflect across that, you'd get this point to be something like this, and this to be like right here. And you get something like that. Just effectively what you're doing is you're going to mirror it. And that should take you to quadrant 1. Your final answer here should be 3, 2, 1. This one is an interesting one. It's an equation with 3 roots. You should be able to see. So our current roots are -3. If we set p of x equal to 0, you should see that our current roots would be -3, -1/2, and 2. But if we were to undergo this transformation, it's asking what the new roots would be. So this transformation is a horizontal stretch. So we have a horizontal stretch. And notice that our b value is equal to 1/2. Horizontal stretch occurs when you have a horizontal stretch by a factor of 1 over b. So if b is 1/2, 1 over 2 becomes 2. So we have a horizontal stretch by a factor of 2. And the way we would express that in our equation, or in our mapping notation, is just x comma y. And this would be 2x comma y. So we're only looking at our x value. So we're going to multiply each root by 2. This is all this is saying. You're multiplying each root by 2. So -3 times 2 becomes -6. -1/2 times 2 becomes -1. And 2 times 2 becomes 4. So our answer should be, so this numerical response asks you to find the values of m, n, and p respectively. So you're asked to basically convert a description into mapping notation. So the way we do this is you have the graph of f of x, which is going to undergo some transformations described by the description. So what I'd first do is I'd say that x comma y, and it's always going to be the same when you have mapping notation, is going to be transformed into 1 over b x plus h comma ay plus k. And now I'd start to fill this out. So we have a vertical stretch by a factor of 1/9 about the x-axis. So a vertical stretch is always by a factor of a, right? If you were to write out our transformations equation, we have f of b x minus h plus k. And it's always going to be a vertical stretch by a factor of a. So whatever a is in our mapping notation is going to be whatever it's described as. So a is equal to 1/9 because we have vertical stretch by a factor of a. So I would say we have 1/9 y and a horizontal stretch by a factor of 1 over 7. So remember when we're describing horizontal stretches, we describe it by a factor of 1 over b. So if we're horizontally stretching by a factor of 1 over b, b is equal to 7. And if b is equal to 7, all we can do is just plug that into our equation. So we have 1 over 7x. Now we have to look for any vertical or horizontal translations. So we now have a translation of 8 units down. You should be able to realize that means k is negative 8. So we have y minus 8, since k is now, if we plug in the value for k, it's going to be negative 8. And that's all the transformations that are being applied. So now if we look at our format here, we have mx, so m looks to be 1/7, n looks to be 1/9, and p looks to be negative 8. So these are m, n, and p. Now we have to use the reference number to match out our answer. So our first value for m should be 1/7. So 1/7 corresponds with 1. So 1 is the first answer. N is 1/9. So 1/9 is 2. So we'll put in 2. And now negative 8 is equal to 6. So 1, 2, 6 should be your final answer. So now this function, so this is a very complicated question in that I think this is like one of the hardest, that transformation questions will get. So making sure you're able to do this would be very helpful. So we have the graph of y equals f of x, and that's transformed to become the graph of g of x, but f of x has to undergo these transformations here. For f, b, x minus 5, and that would be the transformation. And we have the point 4, 6, which lies on f of x. And this point undergoes these transformations described by f of x to become the point 7, 24. So these points match up. So after these transformations applied to this graph, you should get this point. So we have to find the value of b that'll give us these transformations here. So we're looking at the horizontal stretch. So first of all, again, I want to write out my mapping notation. So x comma y is equal to 1/2 bx plus h and ay plus k. 1/2 of b is just b. Since b is equal to b right now, we don't know what b is. X is unknown as well for now. And our horizontal translation would just be h. So I just want to identify all these variables on my transformations right now. So I'd say that a is equal to 4, b is equal to b, and h is equal to positive 5. It's not negative 5, because if it was negative 5, then we'd be adding to 5 just based off our transformation equations. Remember that, I really want to stress that enough. When you're subtracting 5, you're going to be translating 5 units, right? So h is going to be positive. So we're going to have x plus 5, just plugging these values in. And now we can just plug these values in for the mapping. And we get a is equal to 4y, and k is 0, so we don't have to add anything. And now our value of x comma y should be this. And that should be our mapping notation for the graph of g of x. The transformations apply to f of x to give us the graph of g of x. So now if you can see where I'm going, we start off at the point 4, 6, and that should be transformed to the point 7, 24. So the way we do this is we're going to plug in 4, 6 for x and y into these transformations. So we have 1 over b times 4 plus 5, and then you have 4 times our original y value, which is going to be 6. This gives you 4 over b plus 5, 24. So our y value is correct, so we know that we did this part of the transformation or the mapping notation correct. And now we're left with 4 over b plus 5. 4 over b plus 5. We want 4 over b plus 5 to equal 7. So that's all we have to do. We just set 4 over b plus 5 equal to 7. Now you have 4 over b equals 2. And I multiply both sides by b. You get 4 equals 2b. Now, if you divide both sides by 2, you get 2 is equal to b. So now, we're saying that we're stretching this by a factor of 1 over 2, or b would be equal to 2. And that would be our answer here. If you want to double check this question, I think it's beneficial to double check it. So we said b is equal to 2. So if I were to plug in b, so we said this was our transformation. So x comma y turns into 1 over b, which is now 2, times 4 plus 5, and that should be equal to 7. So 1/2 times 4 is equal to 2, plus 5 is equal to 7. So we know that the transformations applied are actually correct, and our correct value of b should be 2 by double checking that. So that's how you do a question like that. The function f of x is transformed into the inverse function y equals f of negative 1 to the power of, or f to the power f inverse of x. So if we're transforming the graph onto the inverse function, it's asking for a possible invariant point. So when we're transforming a graph to its inverse, all we're doing, our mapping, is always going to look like this. We're going to swap points. So xy is going to become yx. So the only way an invariant point would occur is if it intersects the line y equals 0. And if it intersects the line the only way you can have invariant points if it intersects the line of reflection. And when you have an inverse, the line of reflection for inverses is always y equals x. So wherever y equals x is going to be your point that is invariant. So let's check for any y values that will equal x. Does 0 equal 2? No. Does 2 equal 1? No. Does 3 equal 0? No. But 4 equals 4. So therefore, this point could be invariant if it was on the graph y equals f of x.